observatories around the world have recorded a sudden and unexpected change in the trajectory of the interstellar object 3I/Atlas. What should have been just another cosmic visitor discreetly passing through the solar system has transformed into one of the most intriguing astronomical phenomena of recent years. The alteration in course was detected through multiple tracking stations, and the collected data indicates that the object may be heading for an unprecedented approach to Earth's moon. The international scientific community was caught by surprise by the new angle presented by 3I/Atlas. Orbital prediction models had established a completely different route, based on gravitational calculations and the object's initial velocity upon entering our system. The discrepancy between what was predicted and what was observed raises fundamental questions about the nature of this interstellar visitor and about forces that may be acting upon it in unconventional ways. This orbital deviation reveals critical aspects about the object's dynamics. Interstellar bodies normally follow predictable hyperbolic trajectories, determined primarily by the Sun's gravity and that of the giant planets. When an object presents significant alterations in its path, this can indicate anything from active release of volatile material to mass and composition characteristics completely different from those initially estimated. The behavior of 3I/Atlas is challenging established models of how interstellar objects should behave. The gravitational conditions that may have influenced 3I/Atlas's path are under intensive analysis. The Moon, despite its relatively modest size compared to planets, exerts significant gravitational force on objects approaching Earth's orbit. Combined with Earth's gravity and possible gravitational tidal effects, this influence may have been sufficient to dramatically alter the interstellar visitor's trajectory. Small variations in the initial conditions of a space object can completely transform its final destiny. In the case of interstellar bodies, which travel at extreme velocities and traverse complex gravitational fields, even a change of a few degrees in the initial trajectory can result in radically different paths. 3I/Atlas appears to be a perfect example of this principle of deterministic chaos applied to celestial mechanics. The most solid hypotheses about the reason for the lunar approach involve a combination of factors. Experts point to the possibility that the object underwent asymmetric outgassing during its passage through solar perihelion, creating a natural propulsion effect known as the Marsden effect. Another theory suggests that the object's mass was initially underestimated, causing gravitational interactions with Earth and the Moon to be more intense than predicted. There are even those who speculate about an unusual internal composition that could be generating physical phenomena not previously observed in interstellar objects. The data collected in recent hours confirms that the alert issued by major observatories is not unfounded. Consistent signals of acceleration have been detected through spectroscopic analysis and Doppler shift measurements. These observations suggest that the object may be releasing material from its surface non-uniformly, creating a jet effect that contributes to the trajectory change. The anomalous acceleration, though subtle, is measurable and consistent across different observation stations. Comparing with the original projections, the differences are notable and statistically significant. Initial models predicted that 3I/Atlas would pass at a safe distance from lunar orbit, with a comfortable margin of millions of kilometers. Current data, however, indicates a trajectory that could bring the object to less than 1 million kilometers from the Moon, possibly entering the lunar Hill sphere, the region where the Moon's gravity dominates over other gravitational influences. The margin of error that still intrigues analysts relates primarily to uncertainty about the exact mass and outgassing rate of the object. Small variations in these parameters can result in significant differences in final trajectory predictions. Teams are working tirelessly to refine computational models and reduce these uncertainties, but the unpredictable nature of cometary phenomena makes the challenge particularly complex. The scientific impact of this new course is monumental. We rarely have the opportunity to observe an interstellar object on a trajectory so close to a known and well-studied celestial body like the Moon. This configuration allows for direct comparisons and measurements that would be impossible if the object simply crossed the solar system in a distant orbit. Sensitive instruments will be able to capture data on chemical composition, surface structure, and dynamic behavior with an unprecedented level of detail. The possible revelations about 3I/Atlas's internal structure are particularly exciting for the astrophysics community. The way the object responds to tidal forces during the lunar approach can provide crucial information about its internal cohesion, density, and composition. If the interstellar visitor exhibits fragmentation or visible morphological changes, this would confirm hypotheses about the fragility of certain types of cosmic objects formed in distant stellar systems. What this natural maneuver can teach us about interstellar visitors goes beyond the specific case of 3I/Atlas. Each detected interstellar object expands our understanding of the diversity of celestial bodies wandering through the galaxy. Understanding how these objects interact with established planetary systems helps us refine models of planetary formation, orbital dynamics, and even assess potential risks of cosmic impacts on geological timescales. The worldwide reaction has been one of fascination and intense scientific mobilization. Space agencies from major countries are tracking the movement of 3I/Atlas in real time, coordinating observations through a global network of ground-based and space telescopes. NASA, ESA, the Chinese Space Agency, and private observatories are sharing data in a rare collaborative effort, recognizing the unique importance of this astronomical moment. There is a genuine friendly scientific competition over who will make the best observation of the approach. Observatories equipped with the most advanced instruments are competing for optimized observation windows, seeking to capture high-resolution images and detailed spectral data. The healthy competition is driving technical innovations and observational strategies that will benefit the entire astronomical community. Preparation for a possible unprecedented record involves not only ground-based telescopes but also space instruments. The James Webb Space Telescope, solar observation satellites that can redirect their cameras, and even equipment on the International Space Station are being considered to capture different aspects of 3I/Atlas's passage. The event could generate one of the most complete datasets ever obtained on an interstellar object. The next few hours will be absolutely decisive in confirming or refuting the most dramatic predictions. Continuous measurements of position and velocity will define with increasing precision whether the moon will actually be closely overflown or if the object will pass at a greater distance. Each new observation reduces the margin of uncertainty and brings scientists closer to a definitive answer about 3I/Atlas's immediate fate. Specific signals could confirm a second deviation, and observers are particularly attentive to these possibilities. If the object presents new material jets or partial fragmentation during the approach, its trajectory could undergo additional last-minute alterations. The gravitational interaction with the moon could also produce a gravitational slingshot effect, accelerating or decelerating the object and modifying its exit angle from the Earth-Moon system. This is the moment to follow global tracking updates in real time. Major observatories are maintaining open communication channels, publishing technical bulletins every few hours as new data is processed. Scientific communication platforms are broadcasting specialized analyses, and even amateur observers equipped with modest telescopes can contribute position observations that, collectively, help refine orbital models. The passage of 3I/Atlas near the moon represents more than an astronomical spectacle. It is a scientific opportunity of invaluable worth that could redefine our understanding of interstellar objects and their interactions with planetary environments. The big moment has finally arrived, and humanity is watching with all available instruments, ready to capture every detail of this extraordinary cosmic dance.